Okay, hello. In this video we'll be going over mass selection. We'll be revisiting our flying purple people eaters from our epistasis video. And in this example, we're going to want to be breeding our purple people eaters for the maximum people consumption. So we want our top 10% of people eating people eaters to be breeding out of our population. So the problem gives us that our broad sense and realized heritability for this population are 0.85 and 0.67 respectively. Our initial population has a mean people eaten per day of 15, so x naught is equal to 15. And we have a standard deviation of people eaten in our population of 3.2. So the standard deviation is 3.2. Okay, so what do we need to do first in order to determine the selection? Well, we need to find our truncation point. Truncation point is the point at which everything above this point on the curve is going to be part of the population we want. So everything above this is the 10% of our breeding parents. All right, in order to determine that, what we did was we took our initial mean, x naught, and we added 1.282, which is our selection intensity, our standard size selection point. And we multiply that by our standard deviation, added that to our initial mean, and we get 19.1024. So, then what do we do after we have our truncation point? Well, now we need to find our selection differential. Selection differential allows us to find the mean of our breeding parents. So, what do we do to get that? Now we take our selection intensity, 1.755, multiply that by our standard deviation, 3.2, we get 5.616 for S on the graph here. So now that we have S, we can do a little bit more math. Now that we have S, we can move to find our mean of our selected breeders, or our parents here. And in order to do that, we take our initial mean value of our population, add 5.616 to it, and we reach 20.616. Our selection response can then be found by taking 0.67, which is our realized heritability that we were given by the problem, multiplying that by our selection intensity of 1.755, and our standard deviation of 3.2, which will give us 3.76272. So now we have our selection response of 3.76272, and that tells us how far we're going to be moving the curve in our offspring population. So now we can see that the mean in our offspring is going to be 18.76272, which is 3.76272 higher than in our initial population. So we've succeeded in making our flying purple people eaters eat more people. So what would happen if we did this indefinitely? Well, it's not going to be the same every time. You're not always going to be improving by the same amount. In fact, you'll probably be improving by less. There'll be diminishing returns every time you select the top 10%, and that is simply because you won't have as many outliers every time you increase the population through breeding this way. You'll also be probably introducing some genetic problems with your population because you're only allowing such a small percent of the population breed. So any issues that percentage of the population has, be it genetic disorders or hereditary diseases that cause them to die in an untimely way, those will be amplified. And then your population will have issues in other places, but they'll be very good at eating people. So I hope you enjoyed this video on mass selection. I hope it's helped you out a bit. Thank you. Have a good day.